Thank you, Caroline, and more particularly, thank you to the organisers for arranging for me to be here. It's a real pleasure to visit Uganda and see all the work that's going on. So I'm academic trained, but I'm currently a full-time respiratory physician, and I've had a long-standing interest in respiratory allergy, in particular air allergen behaviour. This setting will seed nicely into Richard Cruzella's presentation on aspergillus sensitisation in the Ugandan population next. You'll see that on this diagram, on the first title slide, we have the common sources of air allergen important to us in the UK. We've got the house dust mite, third one along. We've got your dog, we haven't got a cat. We've got birch pollen there, we should also have grass pollen. And on the left-hand side, we've got a fluorescence micrograph of a fruiting head of Aspergillus fumigatus. These are my declarations, none of which are relevant particularly to this conference. So I think it's probably just fair enough to start off with a definition of asthma. Asthma is quite difficult to define because it's almost certainly more than one entity. But it is important to, when you're in the clinic particularly and you're faced by a patient who may have one of many similar, slightly overlapping diagnoses, to just make sure that you've got your facts straight. So central to all definitions is the presence of symptoms, one or more of wheeze, breathlessness, chest tightness or cough, and of variable airflow obstruction. More recent descriptions have included airway hyperresponsiveness and airway inflammation. So putting that all together, you need symptoms, you need physiology, and you need inflammation. If you're in clinic and you haven't got all of those three, then you might be on shaky ground in terms of having your diagnosis right. So, for those of us who went to medical school 30 years ago, you'll remember that this is what we thought of as asthma. Asthma was all either extrinsic or intrinsic, terms that we don't use now. And this is the model of extrinsic asthma. This is the early and late phase allergen response. This actually happens to be an occupational challenge with red flower in a patient with Baker's asthma, but it could be any air allergen. And you know how this works. You breathe in the air allergen, the air allergens are inhaled into the lungs. Those allergens cross-link pairs of IgE molecules on the mast cell, which then degranulates, releasing its toxic mediators, which cause immediate vasospasm, mucosal edema, and bronchoconstriction. And within a very short space of time, and the active component is the red line at the bottom, you get a reduction in FEV1 and the patient becomes breathless. That quickly recovers, and over the next few hours what you see is the results of the chemotaxis and bone marrow stimulation, and T helper cells and eosinophils come rushing into the airway lumen, causing further mucosal swelling and a longer lasting immune response. This is only the response to one challenge, and you can imagine how if patients have a continuous allergen stimulation, then they're going to get both of these processes occurring simultaneously. Is the sound okay, or is it a bit echoey? Is it all right? Yeah. Good, thanks. It's echoey here. The principle of the atopic march is now well established, and so for patients with early onset atopic disease, what we see is that they typically start off with atopic dermatitis at a very young age in the first year of life, then develop food allergy. In our country it's typically egg or milk. Shortly after that you begin to see the onset of atopic dermatitis, and then from mid-childhood onwards the development of allergic asthma. We've often thought of the allergy component of asthma as being, in terms of the individual allergens, as being of equal importance. And so you'd see an asthmatic in clinic, you'd determine on a one-by-one basis, are they allergic to the house dust mite, to cat, to dog, or to grass. But it looks like it's much more interesting than that, and it is important in terms of what you're sensitised to and when that sensitisation occurs. And so the only way to answer these important research questions is to have a birth cohort study. And I'll be showing quite a bit of data from the Manchester Asthma and Allergy study, which is a birth cohort study which was actually started in 1996. And so the children are now 23. What they did in this study is that they followed the children up after birth. They had sensitisation data at years 1, 3, 5 and 8, and they had hospital admission data at the age of 8. And hospital admission with wheeze is a really good hard marker for the diagnosis of asthma. So they're pretty robust about the outcome. What they found is that at the age of 8, you have an 8% chance of having asthma. You have an 18% chance of having current wheeze. Of course, some of those will go on to have asthma confirmed. And 40%, or 4 in 10, will be atopic. But more particularly, what they found is that you are much more likely to develop allergic asthma if you were sensitized at a very early age to many different air allergens. So if you are 1 to 3 years old and you were sensitized at that point to cat, dog, house dust mite at a really early age, then you're much more likely to go on later on to have asthma at age 8. So the number of allergens you're sensitized to and the earlier the age are really important factors in terms of the development of asthma. It's not all about sensitization. Sensitization is all about the presence of the IgE molecule on the mast cell. Of course, you need exposure. But there are skeptics. I've had traditional respiratory physicians that I've worked with some years ago now who would say, why should we even measure skin prick testing? What's the point? Well, to prove the concept, you have to then go and say, what happens if you expose those patients who are sensitized to allergen? Do they get worse? This is a very nice paediatric admission study from Claire Murray in Manchester, published 14 years ago now. It's a long time ago, but it's oft-quoted. And it shows the effects of sensitization to allergen, which is S, whether you're virally exposed, you've got viral RNA or DNA up your nose, whether you're sensitized and exposed to that allergen, or whether you've got a combination of all three, you're sensitized, exposed, and have virus exposure. And what you can see is that if you're just sensitized, or actually even if you're sensitized and exposed to, let's say, mite or cat, the odds ratio for admission with asthma is not particularly high. But if you've got all three, there's great synergy, and that boosts up your risk of having an asthma admission. And so there's an important interplay between the A to B, the presence of IgE in the blood and on the mast cells, whether you're exposed, whether you've got that cat in your house and you've got the antibodies to it, and whether you've got virus infection as well. So this is, of course, the big daddy of all. This is the original house dust mites. This is the original house dust mite. House dust was found to be, allergy to house dust extract was found to be a major risk factor for the development of allergic asthma in the 60s. It was only in the early 70s, I think, that they narrowed it down to the house dust mite and then the house dust mite individual allergens. Now, house dust mite's a bit of an odd beast, really, because you never meet patients who say, I'm allergic to the house dust mite, doctor. The house dust mite makes my asthma worse. They'll come and say the cat makes me worse or the dog makes me worse, because that's obvious. They go into a house with a cat or a friend's house with a cat and they get worse. But mite allergen is different. These particles are heavy, they settle quickly. In order to disturb them and do aeroallergen studies, you need to have pillow fights or volunteers jumping up and down on mattresses to make the dust all airborne. And so the way in which the exposure occurs, it occurs low grade, piecemeal, a few particles per hour from your bedroom surface up into your nose, which is closely pressed to the bed surface. This paper proves that. They used tiny doses of mite allergen in steroid-naive individuals and found that over only 4 weeks there was a real deterioration or worsening of bronchial reactivity or worsening of asthmatic inflammation. So things have moved on a bit since then. You've probably thought for many years that, as I just said, the important mite reservoirs are the mattress, the carpets, the soft furnishings. Well, it's not quite true. They're everywhere. And the development of personal air sampling, and this colleague of mine, Ewan Tovey, has done a lot of work in this area in Australia, very seminal work, developed this personal air sampler which allows you to measure allergen as you're walking around and going about your daily business. It's quite hard to do. And what he found, and if you have time to scrutinise his results a bit later on, is that in the office, in the car, on the bus, at your friend's house when you're having a meal, wherever, you will be mite exposed. And in fact, the in-bed asleep exposure time is only gets around 10% of the overall exposure. So you can't get rid of it. It's the same with pet allergens. Pet allergens are ubiquitous. They're a bit different. They're very airborne. They're sticky, they stick to your clothes, but they also then become airborne. So people who are pet owners walk around in a cloud of their own pet's allergen. You may have colleagues who say, I can't sit next to Sarah because she's got a cat and it makes my chest go tight. Well, your friend is not barking mad. There's a rational basis to this, and that is that pet allergen is so transferable, and if you are highly allergen sensitized to cat or dog, you can easily have that passive transfer cause your chest symptoms. Furthermore, this study that we did some years ago now shows that even if you're in a cat-free house or a dog-free house, you're still exposed to significant amounts of pet allergen. There's a whole literature on trying to get the pet out of your house, trying to get the pet allergen out of your house. The short answer is, to save another lecture lasting about 65 minutes, is that it doesn't work. People have gone to extreme lengths to try and cut down the amount of pet allergen in their households, mite allergen too. This is one of the more extreme series of studies where patients attempted to wash their cats or wash their dog. This proved two things. Firstly, that Fido here on the right-hand side, you could cut down his allergen levels for about a couple of days, but of course they rapidly come back up to normal, and the same thing with cat. It also proved what we know already, which is that dogs love a good bath, and cats will hate you forever for it. Just look at that look. So what does severe asthma actually look like? And this is an example from the clinic that I run. This is a 17-year-old woman. Just to tell you, I'd be interested to know whether you see these patients as well. I'm sure you do. Very typical example of a young woman with very severe asthma. Onset aged 4, with symptoms worsening by the age of 12. She had early milk allergy, so she's a classic example of the beginning of the atopic march. Her chest is very poorly controlled. She's had 6 courses of oral steroids in the past year. Her nose is always blocked. 70% of our asthmatics will have very bad, severe allergic rhinosinusitis or rhinoconjunctivitis, often very poorly controlled and often ignored by doctors. She also has eczema, which was a problem, and 50% of our patients with severe asthma will have severe psychosocial problems. There's a high rate of depression. She had some sexual orientation issues. The death of a girlfriend had occurred 3 years before. Took her a couple of years to come out with that. We then got her in to see psychology, and that helped. But a whole constellation of difficulties. These are her numbers. You can see that she's highly atopic. Total IgE count really high for our population, and a population that doesn't have a lot of parasite infection. Nearly 4,000 with very high levels of allergy to mite, cat, dog, grass, and all the others. We use these control scores which show poor asthma control. She's also overweight, and that's a difference between the asthma studies that we see in Africa and the asthma studies that we see in the higher income countries. Okay, so that's what it looks like. Now, what about Africa? Richard's going to present some data later on asthma prevalence, but just a quick headline here: 1.2 billion population, 50 million with asthma, by derivation 7 million with severe asthma. This is almost certainly an underestimate because the proportions in higher and middle income countries are much higher. We've got a much higher proportion of asthma per total population. Anyway, this is great because it's new data. You haven't had this data before, and it gives you a good start in terms of developing public policy. So, of course, where I come from, we had the Industrial Revolution 200 years ago, and urbanisation of populations has occurred a long time ago. So, what is it? What do we understand about this urbanisation process? And what is it about the rural factors that are apparently protective against allergic disease? Well, I was expecting to find lots of helpful data on parasitic infection that tells me the answer, and I've been asked questions at this conference about that, and it's a field that, to me, doesn't seem to draw many conclusions at the moment. But we have got some really interesting data from Central Europe, and also from the old Protestant religious communities in Pennsylvania and Ohio in the US. This is probably, if you want a review of this, I would recommend Erica von Mutius's review article reference there. But this paper by Stein et al. Is a very nice example. What she did is look at the Amish and Hutterite farming communities in Pennsylvania, Ohio. Now, The Amish came to Northern America, I think it was 300 years ago, if not longer, at some point split, according to religious differences, into two groups. The latter group, the Hutterite, splitting off because of, as I say, differences in religious thought. And they've diverged slightly differently, so there's the same genetic origin, but the Amish have maintained their reliance on using horses for farm transport, whereas the Hutterites are more mechanised. And this means that there's higher levels of endotoxin, of dung and so forth in the Amish farm environment and therefore in Amish homes. And so when they looked at these two populations in detail, what they found that in the Amish, the more traditional community if you like, the levels of asthma innately were 5 times lower than in the Hutterite communities. And endotoxin exposure, a surrogate marker for microbial airborne exposure, was 7 times higher. And there were differences in the innate immune cell profiles in the study volunteers. They then took some of that dust from both the Amish and the Hutterite communities, they extracted it, and they had the traditional ovalbumin Th2 model of asthma. And they took these mice and they squirted some of this dust up the noses of the mice. And what they found was that the dust from the Amish communities was very good at switching off the Mike model of asthma, whereas the dust from the Hutterite communities did not. So there's something microbial about the dust that abrogates or reduces the Th2 allergic response. It's been studied at length to this date. We don't know quite what it is. It almost certainly will not be 1 microbe. What they did find in the mouse was that it was dependent on innate signaling molecules. When you knocked out those two at the bottom, it didn't work. So, what about the situation in Africa, and what data do we have in Africa? And I'm going to show a series of 3 slides from Emmanuel Allergy, a pediatrician who's worked in Ghana, because his work done over the past 20 years tells a really coherent story, I think. First of all, in 2001, he published this article in Ghana in a mixed population, mixed affluence, 50 children with asthma and 50 controls. He skin prick tested them, took everything and did environmental sampling. What he found was a very sort of Western type asthma model with cockroach sensitization, with mite and cockroach sensitization really being strong predictors for allergic asthma in these young Ghanaian children. Furthermore, inner city residence was a risk factor, as was position and citizenship. Finally, you found that most asthmatics had levels of house dust mite in their homes at least as high as that required to cause sensitization. He then reanalyzed the data and published it in a different paper, somewhat later actually, comparing these results in children who went to schools in urban affluent areas, in urban poor areas, and in suburban rural areas. And what he found was that if you had asthma and you're in an urban affluent area, your asthma was much more likely to be strongly mite allergic compared to if you were in a poorer area or a rural area. He then looked at exercise-induced bronchospasm as another outcome rather than diagnosed asthma, and found similar findings, but they weren't quite statistically significant. Again, suggesting that the asthma that we're seeing in young children in Ghana and perhaps other African countries is very much according to a higher income country type model. And then finally, very elegantly, he did the same study 10 years apart. A very powerful model of this, using the same methodology at 2 different time points, and found that allergen sensitization over a 10-year period in Ghana had doubled, gone up 2-fold. And in particular, cat and dog sensitization had gone up between 6 and 10-fold because of increasing pet ownership. So really looking now to having to confirm that asthma is on the move, and what we're seeing now is beginning to reflect the sorts of asthma that we're seeing in the cohort studies from the UK and elsewhere. I don't want to spend too long on this slide, but I want to just try and put severe allergic asthma in context, because it's not the only type of asthma that we see. For many years, we started off talking about extrinsic and intrinsic asthma. Then doctors used to waffle on about phenotypes, which were basically concocted by expert panel opinion. which of course is not necessarily research-based. And in the past 10 years, we've tried to move beyond that and use as much data as possible on cohorts of asthmatics fed into a computer to independently generate asthma clusters of different types of asthma. And if you do this, what you get is you find that you can explain most of asthma according to symptom load or the degree of eosinophilic inflammation. So the patients that we've been talking about are all here. They've got early onset allergic asthma. If they've got minor disease, they're down here with few symptoms and not much eosinophilia. If they've got severe disease, they're up here with lots of symptoms and lots of eosinophilia. We see lots of this group down here, later onset asthma, who aren't particularly allergic, don't seem to be allergy driven. These ones shock you though because they die suddenly, they exacerbate suddenly, and you need a biomarker to justify it, in order to determine how much penicillin they need, because they usually need more than they say they do. On the other hand, this group up here are in the opposite problem of having lots of symptoms. They're often over-treated with penicillin, and they get obese and have severe complications when those can be avoided. So this is thought by many asthma physicians to reflect the totality of asthma as we know it. However, I'll just kind of move on to the mucosal immunity. You see how this has occurred, moved on over the past 10 years from the IgE-driven allergic pathway, allergen, dendritic cell, T cell, IL-4/13, IgE manufacture, mast cell coverage, type 1 immune response. But we've now got this other pathway which is equally important, where things like pollutants, microbes and glycolipids, it's kind of just off the screen there, do not rely on IgE. They bind to pattern recognition receptors, cause the release of these molecules called alarmins. They stimulate this new group of cells and then come down by non-allergen mechanisms to also cause eosinophilic inflammation. Does that explain all that we're seeing in Africa? I think the answer is almost certainly no. You'll know, you'll have experienced more of this than I have. Don't need me to tell you that biomass fuel exposure is a major concern in many parts of the world, in particular the African continent. And it's been highlighted in a number of different studies. So the ISAC study showed that open fire use increased the risk of severe wheeze in children. A recent study from Nigeria shows that biomass fuel use was associated with severe symptoms of asthma in children. Trouble with these studies is, well, there's no trouble with them, they're great studies done in thousands of children across difficult geographical conditions, but you can't measure everything in a study like that. And so in a study like this, we don't know anything about the other bits. We don't know anything about the allergy. The diagnosis is often not secure. You can't go and do exercise bronchial challenges on these children because the studies are simply too big and difficult to do. I'll skip that one in the interest of time, but it's just to show that they are finding the same thing in adults with this emergence of so-called asthma-COPD overlap syndrome in countries of low and middle income category, which is driven by biomass fuel smoke exposure. In terms of the cellular profiles of these children and adults, we don't understand a lot about them, so it's difficult to know whether they plug into that overall asthma map that I showed you earlier. And so this is a real area of unmet need and research potential. Let's just going to spend a couple of minutes talking about fungi. So we know fungi are important in asthma. This is one weekend my colleague Fred Nasser in Cambridge had a really bad on-call weekend. We normally get a couple of asthmatics in over the weekend on September. He had 50 that weekend. And the reason for this was that there had been a great big thunderstorm. And we now understand that thunderstorms cause both the dispersal and uplift of air allergens on the ground, and they also cause spores to rupture, causing the release of very small particles which more easily penetrate the small airways. And you'll see that they found that the peak surge in this level of Didymella, this blue spike here, coincided with a very significant increase in exacerbation rates. It's been well known for some time that if you're sensitised to Alternaria, you are at risk of seasonal severe asthma with a higher likelihood of intensive care admission. Patients with fungal sensitisation tend to be sensitised to more than one. And the common ones we see in the UK are Aspergillus, which Rich will talk about in more detail, Candida, Penicillium, Alternaria, Cladosporium. Just want to make the point that we don't know anything about the importance of these allergens in Africa. In the UK, we do know that if you're more sensitised to fungal allergens, you're more likely to be admitted to hospital. That also goes the same for non-mold allergens as well. But it shows you something about the importance of being allergic or atopic to fungal allergens. Fungi are everywhere. A colleague of mine did this study on pillows in Manchester some years ago and found that if you had a synthetic pillow, you had a tenfold higher risk of a tenfold exposure to you had exposure to tenfold more different fungal species than if you had a feather pillow. So let's move to something that we think we understand a bit better, and that's allergic bronchopulmonary aspergillosis. We know what this condition is. It causes great big plugs of fungi laden with eosinophils and eosinophil breakdown products, which cause lobar obstruction, blocking off whole lobes of the lung and causing lobar collapse. Lots of symptoms, sudden chest pain, difficulty. When you suck these plugs out, which is what we did with this patient 20 years ago, you'll see that there's this really intense underlying red inflammation, which is heavily Th2 driven. Again, lots of eosinophils, lots of Aspergillus-specific IgE, and very high levels of total IgE. So we know that you can treat ABPA with steroids and itraconazole. You can see the fungus, therefore you need to get rid of it. It stands to reason. You don't need to have a degree to work that one out. The concept was then what to do about these patients who don't have ABPA but are just allergic to fungi. What happens if you treat them with itraconazole? Do they get better? Does their asthma get better? And so that was attempted in this landmark trial 10 years ago from Dave and Rob Niven. They used asthma-specific quality of life as an outcome, and over 8 months they found that there was an improvement in asthma-specific quality of life. Unfortunately, when they repeated the trial, the Leicester group repeated the trial using the voriconazole, shorter study looking at exacerbations, they found no appreciable effect whatsoever. We were keen on voriconazole because it has a better side effect profile. And one of the problems with this, interpreting all this, is that, as we know, itraconazole inhibits steroid metabolism. You take a dose of itraconazole or a course of itraconazole, you're on inhaled steroids, you're going to double your steroid load. It may well be that itraconazole is just acting as a steroid boosting agent. That's not the final conclusion. We don't know what is. Almost certainly fungi operate by non-IgE mediated mechanisms as well, which are beginning to be teased out. And again, it's a real area for research potential. So I just want to stop there and just summarise some challenges really. I'd be delighted to take any questions. I think what I've tried to say is that atopic asthma is increasing as societies in Africa, as societies move from rural to urban settings. We've got no comprehensive data on allergen sensitisation or allergen exposure for most of the low and middle income countries. In order to sort this out, because asthma is complex, asthma is more than one disease, you need comprehensive birth cohort studies really. They're expensive, they're big, they're difficult to fund, they're difficult to do, and none have been conducted in Africa. But to get African answers, you probably need an African study. We had discussions over this over the last couple of days. Is fungal exposure likely to be more important in Africa? Because you've got more patients who are going to have had TB, lung cavitation, and Aspergillus colonisation. And are your rural protective factors going to be the same as they are in the US, Ohio, or Central Europe? Just want to make this public health point. No matter what the differences are, I think there are some big similarities, and that most asthmatics will respond to inhaled corticosteroids. And in our country, deaths still occur. We have 1,000 deaths from asthma a year. We always investigate them, and usually the deaths have been completely avoidable, and they're usually down to poor emergency management, access to emergency care, or low concordance with guideline-based cheap medications such as inhaled corticosteroids. And one final thing as we leave, because I think we need to understand much more about the biology of biomass fuel smoke exposure. Thank you very much.